Hello friends, welcome to the class on control engineering. Today we are going to solve the problem on root locus. The problem is being given like this. Sketch the complete root locus of a system having g of s into h of s. This is the g of s into h of s. Now we need to draw the approximate root locus for this given problem. So let us go by step method. So first step number 1 is to find the general information about this. So what are the number of poles? See, so I'm going to consider the denominator term. How many s terms are there? So there are 4 terms are there. Therefore number of poles is equal to 4. Next, consider the numerator term. So that will find out the number of s terms. There are no s terms are there. Therefore number of zeros is equal to 0. Therefore how many branches are there? Since p is greater than z, number of branches, that is n, is equal to p, that is equal to 4. Now what are the starting point of the branches? So that is s. See, always the branches are going to start from poles. What are the roots of s? So s is equal to 0, minus 1, minus 2, minus 3. So I am going to equate this each term equal to 0. Then I am going to find out the root of s. So these are the starting points. Always the branches are going to start from poles. Next one, what are the roots of zeros? We don't have any roots of zeros. Therefore all the branches are going to end to, these are the ending points: infinity, 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 and infinity. Starting point of the branches, and these are the ending point of the branches. This is step number 1. Now let us go to the step number 2. So we are going to draw the pole 0 plot and identify the root locus on the axis, real axis. So I am going to draw the S plane. So what are the roots are there? S is equal to 0, another one is minus 1, minus 2, and minus 3. Okay, first I am going to consider the minus 1 and 0. I am going to draw the imaginary axis. How many roots to the right side? There is only one root to the right side. There is an odd number. So root locus is possible. In the same way, I am going to consider another root, minus 1 and minus 2. Draw the imaginary axis. How many roots are lying to the right side of the S-plane? There are 2 roots are there. Therefore, in between minus 2 and minus 1, no root locus. In the same way, I am going to draw the imaginary axis between minus 2 and minus 3. How many roots to the right side? So there are 3 roots, minus 2, minus 1, and 0. So therefore root locus is possible. So root locus is possible between minus 1 and 0, minus 3 and minus 2. So this is what the prediction. So next one is step number 3. What is step number 3? To find out the angle of asymptotes. To find the angle of asymptotes. So to find out the angle of, before that we should know how many asymptotes are there. Therefore number of asymptotes is equal to p minus z. So that is 4 minus 0, that is equal to 4. There are 4 asymptotes are there. And so what is the formula to find out the asymptote? Theta is equal to 2q plus 1 into 180 degree divided by p minus z. See here, the q value is going to vary from 0. Okay, so how many asymptotes are there? 4. So therefore q value will be 0, 1, 2 and 3. Okay, so this is the formula. So when theta is equal to 0, that is theta naught, that is I am going to substitute q is equal to 0, then theta naught, what I am going to get is 45 degree. In the same way, when the theta 1 is equal q is equal to 1. So theta 1 will be equal to 135 degree. In the same way, theta 2 is equal to 225. Theta 3 is equal to 315. Okay, so next one, this is the angle of asymptotes. Step number 4 to find out the centroid. So what is the formula? Summation, that is centroid, is equal to summation of real part of poles minus summation of real part of zeros divided by p minus z. Okay, so centroid is equal to, what is summation of real part of poles? We have 0, minus 1, minus 2, minus 3. These are the real part of poles. Minus summation of real part of zeros. We don't have any zeros, therefore it is 0. P minus z. How much is this? 4. Okay, so therefore what is the centroid? It is minus 1.5. So this is the centroid. Okay, next, to calculate, step number 5, to calculate breakaway points or break-in points. Okay, to calculate breakaway points. How to do it? So for that we need to consider characteristic equation 1 plus g of s into h of s is equal to 0. So g of s into h of s has been given. So we need to substitute 1 plus k divided by s, s plus 1, s plus 2, s plus 3 is equal to 0. So you have to simplify this and you need to arrive at a equation. So after simplifying this, I got this s to the power of 4, 6s cube plus 11s square plus 6s plus k is equal to 0. So this is the characteristic equation. Now I am going to get the equation for k. K will be equal to minus s to the power of 4 minus 6s cube minus 11s square minus 6s. So this one I am going to consider as equation number 1. Okay, so now I am going to differentiate this equation number 1 with respect to s and I am going to equate it to 0. So it will be minus 4 s to the power of 3 minus 18s square minus 22s minus 6, that I am going to equate it to 0. Now with the help of calci I am going to solve the equation and I am going to get the roots of s. So I am going to 3 roots. After solving, I got s is equal to minus 2.61, then s is equal to minus 0.38, then s is equal to minus 1.5. After solving this, I got the roots of the s. Now I am going to substitute the values of s in the equation number 1 and I am going to find out the value of k. So when s is equal to minus 2.61, so after solving I got the value of k is equal to 0.99. Okay, so when s is equal to minus 0.38, I got the value of k as 0.99. Okay, so when s is equal to minus 1.5, the value of k that I got it minus 0.562. Okay, now see here you can find out that, so k value is positive when s is equal to minus 2.61 and k value is positive when s is equal to minus 0.38. So this means, so these two are valid breakaway points. So these are the valid breakaway points. So this is the step number 5. Okay. What is the next step? Step number 6. Step number 6. What is step number 6? So we need to find out the intersection of root locus with imaginary axis. That is the step number 6. Intersection with imaginary axis. Intersection of root locus with imaginary axis. For that we need to consider the characteristic equation. We already found out the characteristic equation from the previous step. I am going to consider this. That is s to the power of 4 6s cube plus 11s square plus 6s plus k is equal to 0. Okay. Now with the help of RH method, I am going to construct an array. So the highest is s to the power of 4, s to the power of 3, s to the power of 2, s to the power of 1 and s to the power of 0. I need to construct the array. So here the coefficient of s to the power of 4 is 1. Next s to the power of 2, that is 11. Next s to the power of 0, that is k. So what are the coefficient of s to the power of 3, that is 6. Next s to the power of 1, that is also 6. If nothing is there, that will be 0. Now I am going to construct the next array by using the previous two rows, that is 6 into 11 66 minus 6 into 1, that is 6 divided by 6. Okay, so that will comes to 10. So next in the same way 6 into k minus 0 into 1 divided by 6, so that will comes to k. In the same way now I am going to use these two rows to construct this row. So this will be 60 minus 6k divided by 10. How I got it? 10 into 6, 60 minus k into 6, that is 6k divided by 10. In the same way this value will be 0. So next this value, this into this minus 0 into 10 divided by this, I am going to get k, and these are 0. So this is how I am going to apply the RH method. Now for the system to be stable, the first column of the array must be positive. Therefore that means, so these two elements 60 minus 6k divided by 10 must be greater than 0, as well as k must be greater than 0, right? Therefore I am going to substitute. I need to find out the value of k. I am going to equate this 60 minus 6k divided by 10 is equal to 0. After solving this, I got k value is equal to how much? 10. So this is a k margin. Okay. See, this value will be positive for all the values of k less than 10. Not only that, it should be greater than 0. Okay, k must be greater than 0. So k value is going to range from 0 to 10. Okay, when exactly becomes 10, this value becomes what? 0. So that is what the margin, k margin, it will be marginally stable. Okay, this is the value of k. So it between 0 and 10. Okay, so this is the step number 6. Next, what is the step number 7? So to draw the angle of, to find out the angle of arrival or angle of departure. Since in this problem we don't have any complex poles as well as complex zeros, there is no need to find out angle of departure and angle of arrival. So we have to write it as there is no complex poles and zeros. Okay, so angle of departure and arrival not required. So this is the step number 7. Okay, now what is the step number 8? So we need to draw the approximate root locus. Okay, so whatever the data we got it, so with the help of that we need to draw the root locus. So I'm going to draw the plane like this, and I'm going to mark it. So how many roots are there? There are 4 roots are there. I'm going to consider this as a 0 at 1.5 centimeter. I'm going to mark. So like this I'm going to draw. So this is a real axis, and this one is a imaginary axis. Here also I'm going to mark 1.5. Okay. So after this, I think so intersection of with the imaginary axis. Still, I need to find out the intersection of root locus with the imaginary axis. For that, what we have to do is we need to consider an auxiliary equation. So here I am going to consider the s square as an auxiliary equation. So this s square I am going to consider an auxiliary equation. So we have, so I am going to write the equation for this. It will be 10s square plus k is equal to 0. So here I am going to substitute the k value as minus 10. Sorry, 10. That is what I got. K margin is equal to 10. Then what will be the s square is equal to minus 1. Therefore, s will be equal to plus or minus I. So this is what the intersection of root locus with the imaginary axis. It is going to intersect at plus I and also a minus I. Okay. Now I am going to draw the root locus for this. So after drawing the pole 0 plot, I am going to mark it. So this is a 0. I am going to first mark the roots. Okay. Then what else we have? So the another root is minus 1, then minus 2, then minus 3, like this. So we have minus 1, minus 2 and minus 3. 4 roots are there. Next, to find out the centroid. What is the centroid? Minus 1.5. So I am going to mark the centroid. So centroid is equal to minus 1.5. So that is a centroid. Next, what else we got? We got the breakaway points. What are the breakaway points? It is minus 0.381. So this is the first breakaway point, approximately minus 0.38 breakaway point. Next one, another one is minus 2.61. Somewhere here, minus 2.61. So this is the another breakaway point. Okay, what else we found out? We found out the intersection of root locus with the imaginary axis, that is plus I, and this is a minus I. Okay, plus I and minus I. Next, what? So we got the asymptotes. What are the angle of asymptote? Theta naught is equal to 45 degree. First I am going to draw the theta naught approximately, or else we can use the protractor also if you are solving on a graph sheet. Here I am going to draw the approximate. So this is a theta naught, that is equal to 45 degree. Next, theta 1. How much is the theta 1? So theta 1 is equal to 135 degree. I'm going to draw the approximate root locus. So theta 1 is equal to how much? 135 degree. So this will be the theta 2, that is 225. That is a theta 3, that is 315. So this is how I'm going to draw the asymptotes. Okay. Now comes the important step to draw the root locus. Okay. As I told, always the branches are going to start from the poles. So we have 0, -1, -2 and -3. So here I am going to vary the value of k from 0 to infinity. Okay. So it will start from -1 and also it starts from 0 and will approach towards the breakaway point. So here also same thing, start from -3 and start from -2, it approaches towards the breakaway point. At this point, what is the value of k? Is equal to 0.99. Here also the k value is equal to 0.99. Okay. After the breakaway point, here the root locus will break and it move towards plus I and another will move towards minus I. After that, it will follow the asymptote, that is theta naught, and here also theta 3. So in the same way here, after the breakaway point, one of the branch will follow theta 1 and another one will follow the theta. So this is the approximate root locus for the given g of s into h of s. Now comes the writing the stability, that is the step number 9. What is the comment on the stability? That is step number 9. So at this point, what is the value of k when it intersects with the root locus? It will be 10. So here also k value is equal to 10 when the root locus intersects the imaginary axis. So what is the comment of stability? The system will be stable. When it will be stable? So when the k value is less than 10 and it should be greater than 0. So the system will be stable, because after the k is more than 10, the root locus is going to the right of the S-plane. So that is an unstable region. Okay. So whatever the root locus to the left side, that is a stable region. Hence for the k less than 10, greater than 0, so the root locus is lying to the left side of the S-plane, that is a stable region. When it will be the marginally stable, so when k is equal to 10, so that's why it is called as what? K margin. So when it's unstable, when k is greater than 10, when k value is greater than 10, the system becomes unstable. So this is what the comment on stability. I hope you understood. Thank you. Namaste.